What do you mean that two polynomials are perpendicular? Polynomials can be perpendicular now? How does that even work? This video is in response to a question about what does orthogonality look like in abstract vector spaces? To fix ideas, we're going to just talk about the vector space of polynomials with real coefficients and see what does it mean for two polynomials to be orthogonal there. The concept of orthogonality originates from the usual vectors in Rn, where we have a clear idea of what it means for two vectors to be orthogonal, which is that the angle that they describe is a right angle, which is something that we can check in coordinates using what we call the dot product. Two vectors in coordinates are orthogonal, they're perpendicular, if and only if this quantity is equal to 0. And that quantity is what we call the dot product of the two vectors, which more generally is what we call an inner product of vectors in this vector space. And then for abstract vector spaces, we can define inner products in general as some function for pairs of vectors that satisfy certain properties that mimic the properties of the dot product in Rn. And then we say that two vectors are orthogonal with respect to this inner product we have fixed if and only if the inner product of v and w is equal to 0. So what is an option for an inner product for polynomials? There's actually many options, and the concept of orthogonality of two vectors will depend on what inner product you have fixed. So let me give you an example of an inner product that works. For example, you can define the inner product of two vectors, two polynomials in this case, as the integral from -1 to 1 of the product of p of x times q of x dx. And this satisfies all the properties of an inner product, and you should check that it satisfies those properties. For example, if I do the inner product of 1 and x, then I'm doing the integral from -1 to 1 of x dx, which is an odd function, so that integral is 0. And that means that the vector 1 and the vector x are perpendicular with respect to this inner product. Similarly, the vectors x and x squared are orthogonal because the integral from -1 to 1 of x times x squared is the integral of another odd function, so the integral is 0. However, the vectors 1 and x squared are not orthogonal with respect to this inner product because that integral is 2/3, non-zero. So here's a question for you. Can you find an orthogonal basis for the polynomials of degree less or equal to 2? That's a vector space of dimension 3, so 1x and x squared is a basis, but it's not orthogonal because 1 and x squared are not orthogonal to each other. So can you find three vectors that form a basis and such that every pair of vectors is orthogonal? For instance, this is one such example of an orthogonal basis for the polynomials of degree less or equal to 2. So now you can try to find a basis that is orthogonal for polynomials of degree less or equal to 3. And going back to my original pair of polynomials, you can check that these two are orthogonal with respect to the inner product we have defined.